Hi guys, this is a video on solving linear equations. So you would have done some solving in previous years using something called inverse operations. So basically working in reverse to find out what the unknown is, which is basically what solving is. You're finding out what x is or y, whatever your variable is. Just before we go through that, linear equation is, so an equation is defined by two expressions separated by an equal sign. So it contains constants, so numbers, perennials, letters, with a maximum, and the perennials have a maximum power of 1. Okay, so if it has more or less than 1 power, then it's not linear. Okay, most of the time the perennial will not be shown. So in this first one here, x is the perennial. It doesn't have a power, which means it has a power of 1. Okay, we just leave that out. Okay, so I'm just going to go through quickly how to solve these. The first one here, 4x plus 15 equals 7. Hopefully you would have done some version of this with your whatever class you were in last year. So the inverse of how this is constructed, okay, you need to take 15 from both sides because we've added 15. Okay, so 4x is now equal to 7 minus 15. You have to be really good at adding and subtracting directed numbers, so positive, negative numbers. So that'll be negative 8. Okay, if you forget about the negatives, you're going to get this all wrong. Okay, so you have to be really on the money with that. Okay, 4x, the opposite to timesing by 4 is divide by 4. So you divide both sides by 4, remembering that you've still got a negative answer. Okay, so just enlarge this a bit, so I've got a bit more room to work with. Okay, the second one here is a fractional one. Okay, so can sometimes be tricky to think about what step to do first. So with x plus 3 divided by 4 equals 2, you might be tempted to say, well, there's plus 3 there, so I'm going to take 3 away. Okay, so the way I like to think about it is if you, the way you read the question, or the expression, so the way you read this expression here, you do the opposite in reverse order is how you solve it. Okay, so for example, x plus 3 divided by 4, to undo it, you times by 4 and then take away 3 in that order. Okay, so x plus 3, sorry, let's just do it. I'll see if I can get rid of this. Yep, that's what I want. Okay, so I'm going to times everything by 4. Okay, now that will cancel out that, and it will give me x plus 3 equals 8. Okay, now plus 3, I take away 3 to get the answer for that. Okay, so x is equal to 5. Alright, so that's that one. There's the simple ones. We're getting up to some trickier ones here. Fractional ones again. You're going to see this more and more in Year 10. Okay, so this one here has got so a fraction on one side and another fraction on the other. Okay, I'm going to show you a shortcut with this one. It's called cross multiplying. So cross multiply. It's useful to know why you're doing it, why you're doing this cross multiplication. It is following all the inverse operations rules. So that is, do the same to one side, you're going to do the same to the other. But there's kind of a little shortcut in here. So with this one, you times the bottom number on the left with the top expression on the right, and the bottom number on the right with the expression on the left here. Okay, and it sort of forms a cross. That's why we call it cross multiplying. You have to remember your rules from last year. So 2 times 4x, minus 2. Okay, I might just write that a bit neater. So 4x minus 2, is equal to, you've got to keep that in there, 3 times 3x minus 1. Okay, so now I've got two factored expressions on either side. A good idea now is to factorize using the distributive law. So everything outside the brackets gets multiplied by everything inside. Hopefully this stuff is ringing bells. You multiply it out and you get 8x minus 4 equals 9x minus 1. Okay, so this is a linear equation. It has x's maximum power of 1, but in this case we've got x's on both sides. Alright, we need to get all those x's onto one side. Alright, so what we do now is usually we move it to one side and we move it so that it becomes positive. All right, so I could do this two ways. I could move the 9x over here. So I'd take away 9x from both sides. But if I did that, I'd get a negative x result on the other side. So what I'm going to do, I'm going to take 8x from this side and take 8x from this side. All right, which will leave me with, because that cancels out, negative 4 equals, 9x take away 8x is 1x minus 1. Okay? Now the object of this is to get x on its own. So I'm going to plus 1 to both sides. And we finally get, I'll write it all out like this. So negative 4 plus 1 is negative 3. And that equals x. Okay, so finally, usually we have our x's on the left. You can rearrange it like that. Okay, so whenever you have a linear equation with one variable, you should be able to solve it. It is solvable. Okay. Okay, so this last one here is the trickiest of a lot of them. Okay, so we've got a fraction, take away a fraction equals a number, constant. Okay, so one of the things you hopefully remember is that fractions of the same denominator or different denominator cannot be added and subtracted together. So we've got to do something to those before we even start trying to solve it. And what we do is we make them into equivalent fractions with the same denominator. Okay, so the way we do that is we find a common multiple of the bottom two. So find lowest common multiple of 2 and 3. And the way you do that, finding a common multiple is easy. Just multiply them together. And that will give us 6. Okay, so I'm going to turn these fractions into fractions over 6, okay, with a takeaway in the middle. All right, so one of the things you have to do is, so the 3 to 6, so here to here, I'll do this here, I have to times this by 2, okay, so that I actually have to times the top by 2 as well to keep it equivalent. All right, same thing here. Now I have to times that by 3. So I have to do the same to the top. Okay, so to complete my equation, I still need a 4 there. All right, so as we did with the last one, when you have a factored expression, you expand. It's a bit messy here, but 2 times x is 2x. 2 times 2 is 4 over 6. Minus 3 times 2 is 6x. Minus 3 is 6 equals 4. Okay, so that is the first step, or first 2 steps in doing this. Okay, when you have 2 fractions with the same denominator, you can combine them. Okay, so you combine the top and you keep the bottom the same. So we are going to do, let's see, 2x plus 4. Now, this is an interesting one. Because it's takeaway, this takeaway applies to both of these numbers at the top. Okay, and so when you take away 6x, you've also got to take away negative 3. Okay, so when you take away negative 3, you get a positive result. Okay, so that's really important. Alright, well this goes over 6, and that equals 4. Okay, so hopefully it should be starting to look something, we're using all our rules that we've learnt over the past few years. Alright, so common factors, 2x, negative 6, plus 4, plus 3, we add all those, subtract them together. So 2x minus 6x is minus 4x, and 4 plus 3 is 7 over 6 equals 4. Okay, and now we just solve by inverse. So times 6 equals negative 4 minus 7 equals 24. Now we minus 7 on both sides, cancels out, minus 4x equals 24 minus 7 is 17. And finally, we divide it by negative 4. Okay, so x equals, now this is a funny one, and normally this would be if I get a fraction answer, 17 over 4, it is a valid answer, but the way these examples go, they usually should be whole numbers, not should be, but quite often are. So that is sort of raised some alarms to me that I've done something wrong. Okay, I'm going to just write it out as it is, and I'm going to let you see if you can find a mistake. Have I made a mistake somewhere? What have I done? Yeah, so have a crack at that. This is the end of this video. Yeah, I'll talk to you see you next time.